So next we'll discuss boost converter. So boost converter has the following parameters. Supply voltage is 20 volts, load resistance is 50 ohms, and inductance is 100 microhenry, capacitance is 100 microfarads, frequency is 15 kilohertz. So we have to find the peak blocking voltage of switch and peak current passing through the switch. That means we have to design the ratings of switches. First, what is the blocking voltage of switch in boost converter? Okay, so we will discuss the blocking voltage of switch in boost converter. Okay. So here we'll discuss the solution now for this. So here the peak blocking voltage of switch. See, you know, in buck converter, the switch and diode should be able to block the entire supply voltage. Whereas in boost converter, the switch and diode must be able to block the entire output voltage. So here the peak blocking voltage of switch, the peak blocking voltage of switch, the peak blocking voltage of switch is equal to V naught. That means we have to find the output voltage. Okay. So what is the formula for output voltage in boost converter? The formula for output voltage in boost converter is V naught is equal to Vs by 1 minus alpha. So Vs is equal to 20 volts by 1 minus alpha is 0.6. So that is 20 by 0.4. So that comes to 200 by 4, 50 volts. So V naught is 50 volts. So that means the blocking voltage of switch should be 50 volts in this case. Okay. But this is the mistake we do. Normally, we do this type of mistakes. Actually, this formula is suitable only when it is continuous conduction. Examiner did not say whether it is continuous or discontinuous. Then how can you say this formula is valid? So first step is we have to cross-examine whether inductive current is continuous or discontinuous, because that is not given in the problem. So this is the mistake we will do. The moment you see boost converter, V naught is equal to Vs by 1 minus alpha, and you will do it. This formula is applicable if it is continuous conduction, but they did not explain that it is continuous conduction. So first we have to cross-examine whether it is continuous or discontinuous conduction. Okay, so that is why don't follow this approach. So this is the mistake we do. Okay, now how to cross-examine whether it is continuous or discontinuous? See, if it is continuous conduction, I minima should be greater than 0. If it is continuous conduction, I minima should be greater than 0. If I minima is greater than 0, definitely it is continuous. Let us find the value of I minima. So in the case of boost converter, how to find the minimum value of current? Minimum value of current is IL average minus delta IL by 2. So this is the expression for finding I minima. What is IL average in boost converter? In boost converter, IL average is same as supply current. And what are the relations we have in boost converter? V naught by Vs is equal to Is by I naught. So here this IL average is nothing but IL average is nothing but I minima Is minus what is the value of delta IL? Ripple current is alpha Vs by FL. So 2 into F into L. Now, in this case, supply current is equal to, so this is actually 1 by 1 minus alpha, 1 by 1 minus alpha if it is continuous conduction. So, this is applicable if it is continuous conduction. So, Is is equal to I naught by 1 minus alpha, and you can write here V naught is equal to I naught is equal to I naught is equal to V naught by load resistance. So, V naught by load resistance. Okay. So, that means I can write V naught by load resistance into R into 1 minus alpha. So, that can be written as supply current is equal to V naught is Vs by 1 minus alpha. So, Vs by R into 1 minus alpha whole square. Now, I minima is equal to Is is equal to Vs by R into 1 minus alpha whole square minus alpha Vs by 2 into F into L. Now, all values are given. Substitute those values and calculate the value of I minima here. Okay. So, from this, I minima is equal to the DC supply voltage here given is DC supply voltage is 20 volts, load resistance is 50 ohms. So, 20 volts, DC supply voltage is 20 volts, load resistance is 50 ohms, and alpha is 0.6. So, 1 minus 0.6 whole square minus alpha is again 0.6 into 20 by 2 into frequency 15 kilohertz. So, 2 into 15 kilohertz, 2 into 15 kilohertz into what is the value of inductor here? 100 micro. So, 100 into 10 power minus 6. So, simplify this one. What do you get? So, after simplifying this one, we get I minima is equal to minus 1.5 amperes. So, I minima is equal to minus 1.5 amperes. So, minus 1. Actually, this is a contradiction, right? Actually, this formula is applicable for continuous conduction. This formula applicable. So, I have taken the formula for continuous conduction. If I take the formula for continuous conduction, I minima should be positive, but I minima is negative. So, there is a contradiction in this case. That means our assumption is wrong here. See, I have in the initial stage, our assumption is, just see here, our assumption is continuous. See, I have taken continuous conduction and then started. So, this formula is valid or applicable only for continuous conduction. For continuous conduction, I minima should be greater than 0. But here, I am getting I minima negative. That means this is a contradictory statement. So, that means our assumption is wrong. So, we made wrong assumption that it is continuous conduction. Okay, if our assumption is right, I minima should be positive, but I minima is negative. So, the assumption we made is wrong. So, if it is not continuous, it should be discontinuous or at the most at the boundary. So, that means I hope that it is a discontinuous conduction here. If not discontinuous, it may be at the boundary. These are the two options we have. Okay. So, now it is very clear that, see, if it is at the boundary, I should get I minima 0, because even at boundary I minima is 0. It can be negative. So that means the statement is very clear. It is not continuous conduction. It is not at the boundary. That means it should be discontinuous conduction. So from this we came to the conclusion that we are getting discontinuous conduction. So the conclusion is therefore it is discontinuous conduction. So we have just verified now it is discontinuous conduction. Inductor current is discontinuous conduction. So for discontinuous conduction, let us draw the waveforms of VL and IL. Let us draw the waveforms for VL and IL. So now in boost converter, let me draw the circuit diagram also. First mode switch is in the on state. First mode switch is in the on state. So during the interval 0 to t on, in the first mode, the switch is in the on state. See, when the switch is in the on state, voltage across the inductor is same as supply voltage. Go through the circuit diagram. Voltage across the inductor is same as the supply voltage, and inductor stores energy and the current will increase linearly starting from 0. So because it is discontinuous, I minima is 0 here. Okay. Next, when you disconnect the switch here, immediately in the next mode, the diode will on. When diode will on, L is releasing energy through the diode. When diode is on, what is the voltage across the inductor? Voltage across the inductor is minus of V0 minus Vs. Go through the circuit diagram, you will get this. So when diode is on in the second mode, voltage across the inductor is minus of V0 minus Vs. Now L releases the entire energy, so I minima goes to 0 here. So after that discontinuous, IL is 0 and VL is 0. Okay. Now let us make here after reaching steady state, VL average should be equal to 0. So that means this area plus this area, total area should be 0. Then only VL average is 0. So what is this positive area? Positive area is Vs into alpha into time period. So this area, Vs into this length is alpha into time period. Plus what is this negative area? So minus of V0 minus Vs into time is alpha 1 into t. So minus of V0 minus Vs into alpha 1 into t is equal to 0. So from this you can say, we can say V0 minus Vs into alpha 1 is equal to alpha into Vs. So V0 into alpha 1 is equal to Vs into alpha plus alpha 1. So from this V0 is equal to alpha plus, so V0 is equal to alpha plus alpha 1 by alpha 1 into Vs. Okay. So that is the expression for output voltage. Alpha plus alpha 1 is equal to beta. So I can also write it as beta into Vs by alpha 1 can be written as beta minus alpha. So you can use any formula for average voltage, both are right. Okay. Now so here This is the switch current. This is the current passing through the switch, and this part is the current passing through the diode. Current passing through the diode. Okay. Now, if you find out this area, that is nothing but diode current. Average value of diode current. Let us find the average value of diode current now. Average value of diode current. Okay. So let us find the average value of diode current. So average diode current is same as average output current. Okay. What is average diode current? Area by time period. Area of the triangle by time period. So tell me here, what is the area of this triangle? This area is average diode current. This area you can write like this. So here, this part is the ripple current. Ripple current. Of course, that is nothing but I maxima. Ripple current is I maxima here. So here, area of this waveform is area of this waveform half into what is this area? Half into base into height. Base into height. So base is alpha 1 into t. Alpha 1 into t into height of the triangle is delta L. Area by time period. Okay. So time period will cancel anyhow. What is the ripple current in this case? So in this case, ripple current is for boost converter, ripple current is alpha Vs by F into L. Okay, so substitute that value, we get average output current is alpha 1 by 2 into delta I is alpha Vs by F into L. And what is the value of the load current I naught? You can say the load current I naught is equal to V naught by R. V naught by R is equal to alpha 1 into alpha Vs by 2 into F into L. Okay. So from this expression, I will give the formula for alpha 1 in terms of remaining parameters. So from this, alpha 1 is equal to R into alpha by 2 into F into L into V naught by Vs. Just cross check. Alpha 1 is equal to 2FL by R into alpha, 2FL by R into alpha into V naught by Vs. Okay. So alpha 1 is equal to 2 into FL by R into alpha into V naught by Vs. Okay. So we got the value of alpha 1. Now what is the equation for average voltage? I have written here average voltage. I have derived the expression for average voltage. If it is discontinuous, alpha plus, so it is alpha plus alpha 1 by alpha 1 into Vs. Okay. Now let us substitute alpha 1 value here. I can rewrite this formula like this. So V naught is equal to alpha by alpha 1 plus 1 into Vs. Okay. So from this you can write what is alpha by alpha 1 value substitute here. If you substitute alpha 1 value here, you will get V naught is equal to 1 by alpha 1. 1 by alpha 1 means I will write V naught by Vs. V naught by Vs is equal to V naught by Vs is equal to 1 plus alpha by alpha 1. So here, what is the value of 1 by alpha 1? I can rewrite this one as V naught by Vs is equal to 1 plus 1 by alpha 1. So this comes to the numerator. 1 by alpha 1 means r into alpha square because of this by 2 into f into L by 2 into Vs by V naught into Vs by V naught. Now multiplying by V naught by Vs, multiplying by V naught by Vs, what do you get here? So V naught by Vs whole square multiply by V naught by Vs. So this is V naught by Vs plus r into alpha square by 2 into f into L into V naught by Vs. Of course, this will cancel, right? This will cancel here. V naught by Vs into Vs by V naught, it will cancel, right? So from this expression, we can write this one as V naught by Vs whole square minus V naught by Vs minus r into alpha square by 2fl is equal to 0. You see, this is a quadratic expression in terms of V naught by Vs. See, let us suppose that let x is equal to V naught by Vs. So I can write this in terms of quadratic expression ax square plus bx plus c is equal to 0. So here a is equal to 1, b is equal to minus 1 and c is equal to minus of r into alpha square by 2fl. So that is the value of c. So what is the equation for x from this polynomial? What is the equation for x here? You know, so what is the value of x? X is equal to minus b plus or minus b square minus 4ac by 2a. So x is equal to 1 by 2a, x is equal to 1 by 2a into minus b plus or minus b square minus 4ac. So here x means V naught by Vs, right? V naught by Vs. 1 by 2a. So 1 by 2a is 1. Minus b. B is minus 1. So minus of minus 1 plus b square, that is 1, minus 4 into a value is 1, c value is minus r into alpha square by 2 into f into L. Okay. One more root we have, minus. Another root is minus, but it cannot be minus. V naught by Vs, this ratio cannot be minus in boost converter. So that is why another root is not applicable here. Only one root is applicable. The positive root is applicable. Negative root is not applicable. So here plus or minus I said. Only plus we have to take. If I take minus, here minus, x will be negative. That means voltage will be negative. So that is wrong. So that is why only this route is applicable. The second route is not applicable. So from this, V naught by Vs is equal to 1 by 2 into 1 plus square root of 1 plus 1 plus 2 into R into alpha square by FL. So that is the ratio of V naught by Vs. Okay. So from this expression, we can find all those values. So directly V naught is equal to half of 1 plus square root of 1 plus 2 into R into alpha square by F into L into Vs. Substitute the value of R, alpha, frequency and L. What do you get? Just substitute those values. What do you get here? So here V naught is equal to, directly I will write Vs by 2. Vs is 20, right? Vs is 20 here. So supply voltage is 20. So half of 1 plus square root of 1 plus 2 into, what is the load resistance? Load resistance is 50 ohms. 50 ohms into alpha whole square. Alpha is 0.6. 0.6 whole square by frequency. Frequency is 15 kilohertz. So 15 into 10 power 3 into the value of inductance is 100 microhenry. 100 micro. Okay. Into supply voltage is 20 volts. Okay. So after calculating this, we get V naught is equal to 60 volts. V naught is equal to 60 volts. So here the blocking voltage of switch in a boost converter is same as output voltage. So therefore, what is the answer? Therefore, the blocking voltage of switch. Therefore, the blocking voltage of switch. The blocking voltage of switch is equal to V naught is equal to 60 volts. So here the important point is, first we have to cross examine whether it is continuous or discontinuous. To cross examine that, we have done I minimum. I minimum we got negative. So we got, that means it should be continuous conduction. Then the next one is, what is the peak current passing through the switch? So next one is the peak current in the switch. The peak switch current. The peak switch current. The peak switch current. Okay. That is nothing but I maxima. Here for discontinuous conduction, I maxima is same as delta L, that is alpha Vs by F into L. So alpha is 0.6, supply voltage is 20, by frequency is 15 kilohertz, and the value of inductance is 100 micro. 100 micro. Okay. So just simplify this and calculate. We get the peak value of current passing through the switch is, after calculating this, we get 8 amperes. Okay. So here whatever may be the question, whether it is buck or boost or buck boost, first we have to cross examine whether it is continuous or discontinuous conduction. So what is the approach we have taken in boost converter? First I assumed that it is continuous conduction. and I calculated the value of I minima, assuming it is continuous. But the calculated value of I minima is negative. So that is contradiction. For continuous conduction, I minima cannot be negative. So that means it is not continuous. It is not boundary also, because if it is boundary, I minima should be 0. So it is neither continuous nor boundary. So it should be discontinuous conduction. Based on this, we have done. So for discontinuous conduction, I have given the expression for V naught in terms of R, alpha, frequency, and inductance and supply voltage, and then we calculated V naught, and from that blocking voltage of switch is same as V naught. The peak switch current is same as I maxima. I maxima is equal to delta L because it is discontinuous conduction. See, this formula is applicable. This formula is applicable. I maxima is equal to delta L because it is discontinuous. For continuous conduction, this is not applicable. I maxima is equal to delta L because it is discontinuous conduction. Remember that. Okay, right, students?